Hello, Ma'am Ira. This is Ivy Itang, and for today's video, I'm going to tackle about the loss coupling. So, what is loss coupling? In computing systems design, a loosely coupled system is one in which each of its components has or makes us of little or no knowledge of the definitions of other separate components. Sub-areas include the coupling of classes, interfaces, data, and services. Loose coupling is the opposite of tight coupling. So, ang loose coupling kay opposite po siya sa tight coupling. So, advantages and disadvantages. Components in a loosely coupled system can be replaced with an alternative implementations that provide the same services. Components in a loosely coupled system are less constrained to the same platform, language, operating system, or built-in environment. So if systems are decoupled in time, it is difficult to also provide transactions integrity. Additional coordination protocols are required. Data replication across different systems provide loose coupling or inavailability but creates issues in maintaining consistency. Data synchronization. So in integration, loose coupling in a broader distributed system design is achieved by the use of transactions, queues, provided by message-oriented middleware, and interoperability standards. Then there is a four types of autonomy which promote loose coupling: a reference autonomy, time autonomy, format autonomy, and platform autonomy. So, loose coupling is an architectural principle and design goal in service-oriented architectures. 11 forms of loose coupling and their tight coupling counterparts are listed in. So, first is the physical connections via mediator. Second is asynchronous communication style. Third, simple common types only in data model. Fourth, weak type system. Then, data-centric and self-contained messages. Distributed control of process logic. Dynamic binding of service consumers and providers. Platform independence. Business-level compensation rather than system-level transactions. Deployment at different times. Implicit upgrades and versioning. So, Enterprise Service or Bus or ESB middleware was invented to achieve loose coupling in a multiple dimensions. However, over-engineered and mispositioned ESBs can also have the country effect and create undesired tight coupling and a central architectural hotspot. Loose coupling between program components can be enhanced by using standard data types and parameters. Passing customized data types or objects requires both components to have knowledge of the custom data definitions. So, loose coupling of services can be enhanced by reducing the information passed into a service to the K data. For example, a service that sends a letter is most reusable when used the customer identifier is passed and the customer address is obtained within the service. So, ang meaning na kay ang imuhang service kay mo send sa mga letters and ma-reuse siya sa customer nga mo identify siya sa maka-identify siya sa customer, then i-pass po sa customer nga address and then to obtain within the service. So this decouples services because service do not need to be called in a specific order. Loose coupling of application integration in business process automation context can be increased by following a presentation layer integration model in which automation applications interact with underlying automated application through the presentation layer or graphical user interface. So, in programming, coupling refers to a degree of direct knowledge that one component has of another. Loose coupling in computing is interpreted as encapsulation versus non-encapsulation. So, for example, of a tight coupling occurs when a dependent class contains a pointer directly to a concrete class which provides the required behavior. The dependent class loose coupling its signature change without requiring a change to the dependent class. Loose coupling occurs when the dependent class contains a pointer only to an interface which can then be implemented by one or many concrete classes. The dependent classes dependency as to contract specified by interface, a defined list of methods and or properties that implementing classes must provide. Any classes that implements the interface can thus satisfy the dependency of a dependent class without having to change the class. This allows for extensibility in software design. A new class implementing as an interface can be written to replace a current dependency in some or all situations without requiring a change to the dependent class. The new and old classes can be interchanged freely. Strong coupling does not allow this. Then other forms computer programming languages having notions of either functions as the core module, C functional programming, or functions as object provide excellent examples of loosely coupled programming. Functional languages have patterns of continuations, closure, or generators. C closure and LISP as examples of functions programming languages. Object-oriented languages like Smalltalk and Ruby have code blocks, whereas a field has agents. So, ang object-oriented languages like Smalltalk and Ruby, so magamit siya og code blocks. Dili pareha sa a field has agents. So, the basic idea is to objectify, encapsulate as an object, a function independent of any other including concept. So, for example, decoupling an object function from any direct knowledge of the including object. So, see first class function for their insight into functions as objects when qualifies as one form of first class functions. So, for example, in an object-oriented language with a function of an object is referenced as an object, freeing it from having any knowledge or its including host object. The new function object can be passed, stored, and called at a later time. Recipient objects to those functional objects are given. Can safely execute or call the content function at their own convenience without any direct knowledge of the including host object. In this way, a program can execute chains or groups of functional objects while safely decoupled from having any direct reference to the enclosing host object. So, phone numbers are an excellent analog and can easily illustrate the degree of this decoupling. So, for example, some entity provides another with a phone number to call to get a particular job done. When the number is called, the calling entity is effectively saying, "Please do this job for me." The decoupling or loss coupling is immediately apparent. The entity receiving the number to call me have no knowledge of where the number came from. So, ang entity gid ay kay mo receive gid siya sa mga bisag unsa nga number nga motawag, pero wala siya kay bawo og diin to gikan nga number or diin to siya nga country nga gagikan. So, reference to the supplier of the number. On the other side, the caller is decoupled from specific knowledge of who they are calling, where they are, and knowing how the receiver of the call operates internally. Carrying the example a step further, the caller might say to the receiver of the call, "Please do this for me. Please do this job for me. Call me back at this number when you are finished." The number being offered to the receiver is referred to as a callback. So again, the loss coupling or decoupled nature of this functional object is apparent. The receiver of the callback is unaware of what or who is being called. It only knows that it can make the call and decides for itself when to call. In reality, the callback may not even be to the one who provided the callback in the first place. This level or indirection is what makes function objects an excellent technology for achieving loosely coupled programs. Measuring data element coupling. The degree of the loss coupling can be measured by noting the number of changes in data elements that could occur in the sending or receiving systems and determining if the computers would still continue communicating correctly. These changes include items such as: first is the adding new data elements to messages. Second, changing the order of data elements. Third, changing the names of data elements. And the fourth is changing the structures of data elements. And the lastly is omitting data elements. So that's all for today, ma'am, and good luck to me.